People joining us now. Hi, Danny. Nice to see you. If you're there with us. Ruby and Dee are joining us. Just give it 30 seconds here, mate, to get people a chance to join.
Oh, it's under my name. Oh, that's a shame.
All right, so looks like a couple of people jumping on there now.
Norfolk time.
Norfolk time. The internet's not as good as it they're used to over here, apparently. Webinars are a bit of a challenge at times, apparently. So we're recording and we might as well get started. I'm going to put everyone on mute. Welcome, guys. This is real pleasure to introduce this webinar for me today, because I've known of Mr. Graeme Sait's work for some time, and he's something of a, I think we've got some international legends in Australia around this idea of sustainable agriculture, and I think Graeme is very much one of them. Just quick bit of homework, housekeeping. We're going to keep everyone on mute and let Graeme present, and then we'll go to some questions towards the end of about 40 or so minutes in. We might go to questions when everyone's ready to start asking. So if you've got questions, please write them down, have them ready, and we'll have some open mic time with Graeme at the end. But Graeme, welcome to our Nourishing Norfolk Incubator, mate. Thanks for joining us.
Thank you, Adam. Pleasure to be here.
You want to? I'm going to let you roll with this today. You don't need my help asking questions, but let me give us an introduction to what nutrition farming is and what it means for us, and and I'll just let you go from there.
Thank you very much. I'll do that. I'll just get the my presentation up using a PowerPoint here. So, you're basically, you've disabled the participants' screen sharing, so you just need to change that so we can share the screen.
This is what you. Bear with me, right? Sorry.
Okay. While we're sorting that, I'll just point out that it's great pleasure to be talking to some people from Norfolk and to reconnect with the island, because I had quite a lot to do with Norfolk, originally testing a lot of the food producing soils, and then falling in love with the island and buying a property. And the only reason I had to sell in the end was because I simply couldn't get over there with the increasing global travel. But I'm going to change that soon and come back. I'm looking forward to it. Okay, we got it on. We got the screen up now, so we can begin. So we're going to talk about nourishing, of course, and we're talking about market garden strategies, but I sort of extended out to home food production, tied into market gardening. Just explaining from my perspective why I bought that piece of land on Norfolk was because I work in 57 countries. We test soils in all of those countries. And when we tested the soils in Norfolk and discovered that the average organic matter was 12%, that's pretty much unheard of. And I wanted a slice of, for once in my life, to have something with that much organic matter, because humus is the keystone for all soil fertility. So the potential of Norfolk to correct a few deficiencies and then have that base driver of that really massive, wonderful amount of organic matter is phenomenal. And we're going to talk about some aspects around that. But just beginning with the concept of nurturing your own patch, and of course, that could be down to a home gardener, it could be your idyllic little spot in the Pacific. But basically, your garden or your island and looking after it can be your greatest personal contribution to the greatest challenge we've faced to this point, which of course is the climate change challenge. Producing flavoursome, chemical-free, nutrient-dense food, I often refer to the home garden as the ultimate wellness tool. And apart from that production of, the founder of modern medicine, Hippocrates, said, let your food be your medicine and your medicine be your food. And we're finding now, literally, on a daily basis, but certainly a couple of times a week, there's studies coming through showing us the profound medicinal qualities, all these new compounds and their interplay in terms of our health. And so that the bloke who made the comment about food being medicine couldn't have been more correct. It couldn't have been a more profound statement. So you're doing that, if you're eating food that's been well produced, whether it's from your home garden or from a market garden. But the other story about just your involvement in the garden is that we're now finding, of course, hugely important in this COVID times, but we're finding that the garden is a primary stress reducing tool. In fact, the smell of a healthy soil, if you think about the smells that appeal to you, me, it's probably a baby's head, which smells for good reason because the baby emits chemicals to make you want to cuddle it. Freshly baked bread, freshly ground coffee, but actually top of the list for me is that delicious smell of a healthy soil. And what you're smelling is a group of organisms called actinomycetes that produce volatile chemicals that give that delicious smell. It's a direct representation of the health of that soil. The better it smells, the better it is. But now we know that there are actually biochemicals coming from soil that boost your production of serotonin, which of course is the feel-good antidepressive biochemical. So pretty good story and a pretty good reason to get out in the garden. So, the concept of not buying your food from either fresh suppliers or growing it yourself, and it may be more applicable, I don't know, over here than it is on the island, but the basic concept of bundling of food from faceless suppliers, basically, if you're a producer of that food, you say, well, my stuff's just going with everyone else's. It doesn't really matter how good it is or what the quality is. So there's less motivation to produce clean quality food, as opposed to if you're directly branded your food and your name or faces directly to that. So the rise of farmers markets, which have become a phenomenon. On the Sunshine Coast, there are 69 farmers markets every week for a population of 400,000. But that and vegetable boxes and so forth, it all comes back to consumer desire to put a face to your food. People want to know how that food was produced, who produced it, what their motivation was, and how well produced that food was. And often, were there many chemicals involved? And on that note, in my travels, well, I'm talking the past at the moment because I've not gone anywhere for 6 or 7 months, but basically, I find vegetable growers across the globe who won't eat their own produce, and it's not occasionally, it's almost every time. Conventional vegetable growers say, no, don't touch that, mate. It was just sprayed yesterday. They have their own patch out the back to produce food for their family, which is, there's something wrong with that model. Food miles and logistics of moving food around and picking fruit unripe and ripening it in storage produces less vitamins, less antioxidants, less flavour. So, one of the ways that either eating food that's been recently harvested acquired from a farmer's market or market garden scenario, or producing it yourself, basically allows you to eat or have access to champagne food. There's a tremendous unrecognised loss of nutrition associated with storage of food, and people often don't realise that. And it's a really good reason not to make a salad and eat it over the next 3 days, because ideally you make what you're going to eat, you eat it, and give the rest to the chooks. Basically, just to give you some example of the scale of that, a snow pea, for example, 50% of its vitamin C, and it's quite a high source of vitamin C, but 50% within 12 hours of harvest. You're eating snow peas that were harvested several days previously. So I understand it's quite a dramatic loss. Sweet corn, 40% in the first 30 minutes. It's the fastest known loser of nutrition. You know, if you boil your pot before you pick your sweet corn, pick it, drop it in, put a little bit of salt, pull it out. 10 minutes is all that's required. Put some butter on it. Oh my God, that is champagne food. That's how corn was supposed to taste. So, as we said, you're sort of missing the benefits of the garden or the whole benefits of fresh food if you're not eating it as soon as possible after harvest. Now, this is pretty much a permaculture concept, and increasingly, as we're seeing the model of agriculture move into diversity rather than getting bigger or get out, we're seeing this almost diversify or get out model evolving globally. Some of the permaculture principles got huge roles in commercial horticulture and agriculture generally, but whether you're a home gardener or a commercial grower, lucerne is of course a legume that's grown as a fodder crop, but wonderful plant to have in a market garden or in your home garden. You know, you all know the obvious thing. It's a legume that produces nitrogen, but the second benefit from all legumes, including lucerne, is that they exude acids that break the bond between phosphate and calcium that tend to lock together because one's negative, one's positive, and become insoluble. So you're releasing the two most important minerals for the most important process called photosynthesis through this release of acids. You'll also find that fungi that are lacking in most soils, and the biggest story from a biological perspective is we need to improve our fungi to bacteria ratio and get more of these precious beneficial fungi back into the soil. They're the creatures that create that wonderful crumb structure that you can't buy from a bag. And so the acids, that's what fungi love. They'll accumulate beneath the roots of a legume and you'll have that crumb structure developing. The leaves of the food, in fact, there are supplements based on what they call alfalfa and what we call lucerne, because it's highly alkalizing, amazingly nutrient dense, and a whole range of antioxidants and phytonutrients present. So you can add it to salads, you can add it to green smoothies. The edible flowers are absolutely delicious. If you've not tried them before, they are so sweet and so nice. And then of course you can chop and drop, and that's the big concept, particularly in a permaculture garden, because the best fertilizing mulch, the most beneficial of all mulches is lucerne, and you just can cut and drop it and it grows again. You cut and drop it. That attracts an organism in the soil food web called protozoa who love lucerne, and earthworms follow very closely thereafter because they love protozoa. So it's a wonderful fertilizing mulch. Number 3 is the concept of using worm juice and understanding the benefits of earthworms and understanding that there's a whole suite of beneficial organisms that are incubated inside the gut of the earthworm, and they don't come from anywhere else. You can't just get them from the soil. If you haven't got earthworms, you haven't got that group of nitrogen fixers, phosphate solubilizers, potassium solubilizers, disease protecting substance, and so forth. So tremendous benefit to run water through an earthworm bed or an earthworm farm. Or in this case, in the bottom corner there, you can see these. This is what I've got on my farm, a dozen of these. That's taking a 1,000-litre container, cutting the top rung off, cutting the top slice of the plastic lid off, which is 30 centimetres deep, drilling a whole series of 1.5 mil holes, dropping that plastic top down into the bottom, and then putting a lid on the top of that, painting it because they don't like light, and then starting your farm. And you've conveniently, if you put on a couple of concrete blocks, as you can see there, you've got the tap where you can put a 20-litre bucket under, you can run the water to the top, you've created a 700-litre reservoir at the bottom, and that's a perfect source of worm juice that you can then brew like a compost tea. You can put it directly out and you can do that for a couple of $100 on that scale, which becomes, you know, much more user-friendly than just these simple little toy worm farms that you see around the place. So great concept. And worm juice has become we don't sell it, but it's a hugely commercial product. There are broadacre farmers that have turned their farms around by liquid injecting worm juice. So it's quite a good story. just a few 7 reasons to bring back your earthworms. And I did notice in some of our soil work there that there is a lack of earthworms on Norfolk, so this is of particular interest. They're little fertilizer machines. Look what comes out the back end. I mean, it's remarkable. 7 times more phosphorus, 10 times more potassium, 5 times more nitrogen, 3 times more magnesium. You can't have 10 times more calcium. It's the most abundant mineral in the soil, but 1.5 times more calcium than the surrounding soil. You know, literally what comes out their back end is they are a little fertilizer machine. Seriously increasing the word infiltration is a hugely important word in the brave new world of climate change farming. You know, when you do get rain or you get a lot in a short time, how much of that is absorbed into the soil is what infiltration is, and it's massively important because if it's running off, it's taking topsoil with it, and we're losing 7 to 12 tons of topsoil per hectare per year, and in 60 years there's 0 left. It's a huge story. So earthworms in that context massively important. The holy grail of biological agriculture is 25 earthworms per shovelful as an average. If you do it, you know, once a month for 3 months, and that's your average, because they vary at different times depending on soil moisture, and they'll go down deeper in the dry and so forth. But basically, if you can achieve that average, what you're contributing to your soil is 300 tons of earthworm castings, that wonderful fertilizer, per hectare per year. Now, go out and buy some earthworm compost. It's $1 a kilo in Bunnings. It's $200 a kilo, $200 a ton if you're lucky, buying it in bulk. So you just got 300 times 200 is $60,000 worth of free fertilizer. You might be starting to recognize the value of earthworms at this point. And we talked about that 1.5 times more calcium. Where's that coming from? Well, you've got a limeworks with an earthworm. You've got a calciferous gland, which has calcium carbonate to everything that passes through its body. You've got earthworms going down and transporting minerals that would otherwise be too deep for the roots to access, and they're bringing them up. You're composting, and this is huge. If we talk about the value of organic matter relative to climate change, which, you know, normally I talk much more about and we might touch on a little later, earthworms compost 4 times faster than the normal decomposition in the soil. So basically you're creating humus, which is sequestering carbon from the atmosphere effectively 4 times more rapidly if you've got earthworms present. That's huge. I mean, we should be paying people to do the things that build earthworms. They incubate bacteria that are invaluable, as I mentioned. In fact, it's not just bacteria, there's a whole suite of organisms that are only created in the earthworm's guts and come out in the earthworm's poo or in the liquid that you run through the poo. And basically, one other little story about, so you might say, I'm on Norfolk and I don't have many earthworms, what can I do about that? Well, one of the things is quite simple, and it does involve that plant we talked about earlier. You can make what's called a lucerne tea. Now, protozoa are one of the key groups in the soil food web. They love lucerne. There are 3 forms of protozoa, and all of them are found in really high numbers in lucerne hay because it's got so much protein, and that's what they love. So you can take that lucerne hay, and you can do it in a 20-litre bucket, you can do it in a 200-litre drum or a 1,000-litre container. You put some molasses and liquid fish. That's the food that the protozoa loves. It will come off the hay and into the water and start subdividing. Actually, it's more than 24 hours. I said 24 hours. We found it's 2 days that you need to brew. But you've got basically a tank like sardines full of protozoa. You put them in the soil, and it's so quick that the earthworms, where they come from, they bring it and they arrive. I mean, I had a wine grower, a viticulturalist from South Australia, heard my talk, said, I'm going to do this, checked his soils. He had 1 earthworm, 60 acres of wine grapes, 1 earthworm per 11 shovelfuls. He did a lucerne tea at 100 litres per hectare, and 6 weeks later he had 11 earthworms that's a 10,000-fold increase, 11 earthworms per shovelful from 1 per 11 shovelfuls. So that was a tremendous increase, and the soil changed, and the earthworm castings started showing up on top, and the soil structure changed, and so he came into the 4-day course on the strength of the results he'd seen. Number 5 is quite basic, and you can see the chart in the right-hand corner. It's just the importance of the link between nutrient uptake and soil pH, and the aim is to try and get somewhere around 6.4. If you can see the width of the bars there, the minerals, the nitrogen, phosphorus, and so forth, and then the pH across the top, where the bar is widest, the bar's running across the page, where that's widest, that's where most minerals are most available. And you'll see at 6.4, basically, everything is most available. So that's what we're aiming for. That's the perfect soil pH. And that's it's weird because if you're checking your own urine pH or saliva pH first thing in the morning, 6.4 is a healthy human. The new finding is you can squeeze some sap from a plant leaf, and the plant is healthiest and most resilient at 6.4. So, a cell is a cell is a cell, and 6.4 is the figure that we're chasing. So you can test your soil, with an inexpensive kit from the hardware store. On Norfolk, you're going to need some limestone. That's one of the things. Sometimes gypsum can be involved, but you've got to be careful with gypsum if you've got acid soils, because the sulfur can actually create problems. So it's only applicable if the soil's over pH 6 to use gypsum. But calcium's hugely important because it basically flocculates the soil. The large calcium ion with 2 positive charges grabs hold of a little particle of clay on either side, pushes apart that clay and opens up the soil for the most important of all nutrients, which isn't N, it's not P, it's not K, it's not even calcium, it's called oxygen. And oxygen moves in and the roots use it, and the organisms crowded around that root use oxygen, then they breathe out and CO2 flows up in the plant leaf with thousands of tiny pores called stomates, sucks up that CO2, combines it with water and sunlight, and so begins the process of the planet's most important single thing, which is the glucose building block of all life. That's how carbon chemistry comes about. That process, photosynthesis, is the single most important process on the planet. So number 6 is recognizing and understanding the potential. And you can see in the bottom right-hand corner at one point when I was over on Norfolk, we had a field day and I taught people how to make their own garden. We had to dig all the kaikuru out of this patch that had been sitting with lawn for a long time. And we taught about mulching and putting in certain composts and making certain teas and putting them in there in the correct nutrients. We discovered that Norfolk, when we did all the tests, was lacking in certain minerals like copper and boron. Every soil was deficient, so we made sure they were all present. And that was just a few short weeks later, a fully productive edible garden. I think it was 6 or 7 weeks. Down on the right-hand corner, nothing eating anything, just a really nice, healthy garden. As an example of the possibility of working with minerals, microbes, and humus. So the problem often with intensive horticulture and the home garden is too much of a good thing, what I call the more on approach. If a little bit works good, let's put more on, and that's not a good outcome. And what we see is very high levels of phosphorus, massively high levels in most home gardeners from, the dynamic lifter or the chicken manure that you used. And phosphorus then shuts down calcium, potassium, zinc, iron, and copper. And 3 of those minerals are really big players in having a resilient crop that doesn't have disease. So what you've sort of nailed yourself into at that point is that you've got to bypass the soil to address those deficiencies. You can't put zinc into a soil with high phosphorus because the phosphorus just locks it up. So you've got to go in through the leaf. And that's where foliar fertilizer, full stop, it's 12 times more efficient than mineral delivery via the soil. So it's a direct injection of nutrition that bypasses the mineral dynamics in the soil. You just go straight and fix the issue, green up that plant. Your other job, you're managing gas exchange, how freely oxygen moves in and CO2 moves out. That's calcium opening it up. It's called the calcium to magnesium ratio to be exact. And then you're managing chlorophyll, the green pigment that houses the little chloroplasts, the sugar factories. And that's what the better you do chlorophyll management. You don't want stripes and blotches and pale colors. The better you'll do. So basically the foliar root will give you that greening effect, which then pumps more sugars down into the roots from producing more sugars and has a biological effect. So here's a few tips for foliar fertilizer. And we've got broadacre growers with 1 million acres in one area who are basically the huge foliar roots that we use for fungicides and now use for foliars to get back and address the root cause rather than treating symptoms constantly. So basically here's a few little tips if you're going to get into foliar spray, if you're a market gardener or a home gardener for that matter. Direct spray on the underside of the leaf. Don't spray in the middle of the day. It's basically the stomates. So you can see on the top right-hand corner that little mouth. That's a stomate. Those little pores on the underside of the leaves that suck in the CO2 and begin the whole process of photosynthesis. They're accumulated on the underside of the leaf, and they close up in the heat of the day. So you're wasting your time foliar spraying. You want to go in the morning or in the evening. Calcium is probably the most important of that. Almost every crop requires a foliar calcium. Why is that? Because calcium is the slug of all minerals. It's the most immobile. The minerals vary hugely in their mobility. Some minerals rush into the plant. NPK are supermobile through minerals. Calcium's not. It moves slowly to the plant, it moves very inefficiently around the plant and into fruit and so forth. And it's massively important for flavor and shelf life and so forth, and resilience, protective qualities of the plant. So we want to strengthen the cell wall with calcium. So we foliar spray calcium. And trace minerals, for example, you can do it so efficiently to make sure that you've got that full spectrum, which is the basis of flavor, shelf life, and medicinal quality in that food. And then there's the concept of measuring. It's important not to drive blind if you're trying to produce high quality food. So there are several, in some cases, quite inexpensive monitoring tools, and probably the most important of them is a simple little tool called the refractometer. You can see it there in the top right-hand corner. You can see what you're looking when you squeeze a little bit of juice. You put it under the plate, the sloping plate, you hold it up, the light refracts through the dissolved solids in the plant sap, and you're measuring your skills as a chlorophyll manager. You're measuring your skills as a grower. You're measuring something called Brix levels, and the higher the Brix level, the more flavoursome the food, the greater the medicinal value, the longer the shelf life, and the more problem-free will be that growing experience. So it's a hell of an outcome if you can lift your Brix levels. And interestingly, it can also be used as a calcium meter. So if you look at what looks like an old school fuel tank down the bottom there, you can see the 0 to 32 Brix axis up the center, and the two hemispheres and where they join. You can see that low Brix on the left, or on my left, I'm sure, I suppose it's the same for you. The Brix of 4 is where it crosses, very low Brix. But most importantly, that sharp, distinct separation between the two hemispheres, that's what you never want to see. What you want to see is that much higher Brix of 12 on the right, and you want to see that fuzzy separation between the halves of the hemispheres. As you can see there, you're seeking the fuzz, basically, and the fuzzier it is, the better your calcium. Calcium, arguably the most important of all minerals for a whole variety of reasons. We call it the trucker of minerals. It governs the uptake directly of 7 other minerals, and of course it governs cell strength. So stem strength, resilience against both disease and insects is calcium based. So we want to look after our calcium. The refractometer tells us whether we're doing that effectively. A relatively new finding, I mean, it's probably 20 years now, but in the bigger picture, Bruce Tanio, a brilliant scientist from the US, discovered the pH of plant sap, as I touched upon earlier, is a really good guideline. So again, you squeeze a little bit of juice from the leaf of the plant, not the fruit, the leaf, and you can, I mean, there are pH meters, sap pH meters, the specialist meters for the job at $200 or $300. So this is something you can do inexpensively. You can take a set of simple pH strips, and basically you're chasing a pH of 6.4. And so you squeeze a little bit of sap onto that pH strip, and if you get 6.4, as you can see in the top right-hand corner has been achieved, that will be the most resilient plant. If it's 5.4, you're lacking in alkalizing minerals. So just like the soil sweetening minerals are calcium, magnesium, potassium. Well, that's the same story in the plant. If you've got a low sap pH, you've got to address 1, 2, or 3. And you've got to figure which that is, unfortunately, which there is a whole process of exclusion if you've got a few other meters. But in the home garden, you know, it's very commonly going to be calcium, but it could be magnesium, it could be potassium, and there's a few other signs that will tell you which that is. So number 8 in our list of practices or principles is how important organic matter is in the bigger picture. So humus is really, and that's what I said, 12% organic matter. Just have a mouthful of coffee here. 12% organic matter in Norfolk soils is just the most wonderful starting base. That if you fix that, to understand from a terrace, the whole world's looking for food with forgotten flavors and greater medicinal qualities. You've got the building block to do exactly that, and the potential for you to become like a foodie center. That the food that people are buying, they know has come from that base. And you know, it should almost be part of the advertising that there's no one that's got 12% average. You guys have. And then you build on that by correcting the deficiency of minerals. You've got this food that's unparalleled. As if people from all over the world aren't going to come to sample that, because everyone's into food. It's just what it is. It's one of the most important things in the world for most people. So let's talk about humus and what you've got plenty of, which is such a great story. Sweet smelling soil chocolate created by microorganisms and serves as their home base and support system. So it's the storage and delivery system for all minerals. So minerals you put in the soil, how do they stay in the soil? Well, there's clay colloids, little ball of clay that has negatively charged little Velcro sites that hold positively charged minerals and holds them so they don't leach. But what about the negatively charged minerals? Half of the minerals are called anions that are negatively charged. What stores them? Well, humus is the only thing that can store them. It has positively charged valproate, grabs hold of very leachable things like nitrogen, sulfur, boron, and holds on to them. And it also can hold the positively charged. It's the only thing that holds everything, which is, you know, a great story in terms of retention of mineral. But it's not just holding minerals, it's understanding there's a microbe behind every mineral, and humus houses the microbes. There are nitrogen fixing organisms, there are iron reducing organisms, there are potassium solubilizers, there are manganese reducing organisms, there are phosphate soluble. There's a microbe behind every mineral. The higher the humus, the greater the delivery of minerals into that food. And if you make sure those minerals are there and then you can deliver them efficiently, which you can because you've got the humus to do it, that is a wonderful outcome. So houses the microbial exudate soil, and we start understanding soil biology. We understand they're spitting out all of these substances that can be usually looking after their host, the plant, understanding that they're at the nexus of the most important principle on the planet. So the most important process on the planet, which is photosynthesis, the plant's producing sugars, as we mentioned, combining water, sunlight, and CO2 together, creating glucose, a building block for everything in the plant. You know, ties it with minerals and does everything, but it pumps half of its glucose down into the roots because the roots need it for everything they do. But then the interesting thing happens. The plant pumps out 60% of that half, 30% of its total production of its most precious substance, it gives away. It gives away to the army of organisms surrounding that root, waiting for their daily feed, and in return, they give back. And if there it is, at the juncture of the nexus of the most important process, the most important principle, some would argue, on the planet, which is give and you shall receive. Now, some people don't realize that till they retire, donate their time and say, what's this feeling I'm feeling? And they're feeling peace and harmony they've never experienced because you don't get what you don't give. So it's a central principle. And there it is at the most important process on the planet, where we all came from, the building block of all life. The glucose molecule, give and you shall receive. And the organisms, of course, are largely located near that root to get that feed of sugar, and they then start fixing nitrogen and delivering minerals and protecting that plant from disease and producing plant growth hormones to look after. I look after you, you look after me, is the story there. So the higher the humus levels, the greater the nutrient density and medicinal value, the less the need for stressful pest management, and the greater your farming pleasure is the outcome. So it's a wonderful situation that you've already got and you can build upon. Compost is the cornerstone of soil vitality. The very best of all compost is actually vermicompost. In one study, it was shown to be 20 times more powerful than the next closest second compost. Profound source, it can have as many as 30,000 different creatures in a teaspoon. 5 billion actual total number, but up to 30,000 different organisms. And of course, it's also a stable source of humus that you've created to put in the soil. And basically, it's shown to trigger a lot of organisms that then reclaim the humus building potential of your soil. So you can even build upon your already good organic matter levels. So how do you build a compost heap? Well, basically, I don't think you can access council mulch over there because of your fire ant problem. That was the problem when I was there. I'm not sure if that's changed, but it's basically taking straw, prunings, autumn leaves, whatever. That's called carbon layer, brown layer. And you make a layer of that, and then you're going to put your nitrogen layer, which is going to be the green things, or it can be manure, animal manure, which is high in nitrogen. So green waste, lawn clippings, manure is going to be your second. And on each layer, you build your brown layer, you sprinkle some lime, some crusher dust if you can access it, some previous compost, which serves as an inoculum. You water down that layer. Then you put your next layer, which will be the green layer, then your next layer, the brown layer, next layer, the green layer, and then you cover it. And then it'll start warming up quite quickly, and you're going to have to turn it a few times over the next 3 months. It's really quite simple. You can see how simple you can make a little one cubic meter beds up in that top corner. That's 1, 2, 3, 4, 5, 6, 7. Probably hardwood pellets would be best because you can just nail them together with 4-inch nails, and partly they'll hold there and stand there and do the thing with nothing much more than that. And you've just created 3 1 cubic meter beds for free pellets. We give those away because we've got heaps of them laying around. So number 9 or 8 is the concept of building a disease suppressive compost. And this involves a wonderful organism called trichoderma. Trichoderma is something of a marvel. It's one of my favorites, and I love soil organisms, but it's right up there amongst the very best. It controls over the disease. It produces humus. It's a cellulose digesting organism. solubilizes phosphorus. It pumps out a whole series of root growth hormones, so you get a bigger root area always when you utilize it. And it also stimulates plant immunity. There's 3 identified biochemicals that boost plant immunity. The story with that is that anything, it's called immune elicitation, anything that boosts immunity boosts yield. So that's a good story if you're trying to create more of something. And you can produce a trichoderma-based compost in just 4 weeks. And then you can put that around, use that around your plants or however, or you can make a trichoderma compost tea to manage many diseases. So you can basically, how you do that, it basically involves just straw and cow manure, equal amounts. You make a wire bin, as you can see down the bottom there. You can just do that with chicken netting and 4 steel stakes, if you like. It's not how it's done there, but that's what you can do, and it's what we do when we demonstrate this. You mix the whole thing you mix the cow manure, equal amounts of straw and cow manure, and you layer it like a compost, and you water on some trichoderma spores on each layer. And then you finished it, you've got your whole mixture, and you've wet down each layer so that you've got the spores through the entire thing. And then you walk away, and 4 weeks later you come back, and here's this wonderful black, you can see the greenish white hyphae throughout it. And you've actually taken 100 grams, you've actually made 50 cubic meters of trichoderma inoculum, which is about 50, well, it's a huge amount. It's about $50,000 worth if you wanted to get down to the cost of an inoculum. So it's a tremendous little strategy to utilize this organism. You can see it at the top there, it's eating pythium. It's a disease called pythium. The blue tube is a pythium hyphae, and you can see it's wrapping itself around and just sucking the guts out of the pythium, basically. And that's what trichoderma does to over 30 different diseases, including some of the biggest diseases. There's also a different way you can compost where you don't do anything. So this isn't like the one where you've got to turn it, and that you can create a compost in just 8 weeks. And this is putting beneficial anaerobes. We have a product called BAM, but there's something called EM you might have heard of. You can do the same thing with that. And basically, you build your compost pile very similar to, layer by layer, making sure you've got some of the inoculum through each layer with the water. You water on with a watering can or pump it on if it's on a larger scale. And then you cover it over just like a silage pit. It's got to be completely covered with plastic or canvas or whatever, so it doesn't breathe. And 8 weeks later, you pull off the cover, you've done nothing. So that suits a lot of farmers who want to have, they've already got a lot of jobs, they don't want another one. And you've got this beautiful compost that's super disease suppressive. Just to give you some idea, the bloke on the left-hand corner there is the founder of EM, which is now most Asian countries have got some form of what are called effective microbes, these beneficial anaerobes. And we haven't really embraced it in the US and Australia and Canada and so forth, or the UK to the same level, but it's getting there slowly. And what our BAM product is just an extension with 5 new species added to EM, basically. But wonderful concept and so simple to use. But just to give you an idea of the potential benefits, I mean, nitrogen fixation accelerates compost, as we mentioned, suppresses a whole range of pathogens. You can use it to break down residues, to clean stock water, and it also serves as a probiotic in that stock water, so it's good for the animals. It's actually similar to our BioBubble product in composition. A living fertilizer, it can clean septic tanks. You put 500 ml into your tank and there's no smell. I've done it on one of my farms. It works beautifully. It can even be used, a company buys our BAM product, mixes it with essential oils, and they have a different one for the bathroom, the shower, and the kitchen, and the bugs actually eat the dirt off. And you can also use it to deodorize smelly, or dogs. I love dogs. You pat a dog, your hand sometimes your hand smells for 3 hours. It removes the dog smell. It actually takes away knocks out the anaerobic organisms that are creating that smell. And the same deal under your arm. If you're trying to get rid of BO, you can use these organisms to do that. So, and that's just talking about making your BAM compost, which I've already explained. It's just basically an anaerobe. You've got to cover it over on whatever scale you're doing it when you're finished. And you've layered it up just like an ordinary compost layering up, and then you cover it, you don't turn it, you just leave it for 8 weeks, and then you've completed. Supporting your workforce. So number 9, we're talking now about, just have another mouthful of coffee here. Recognizing that the soil life is your hidden workforce, and basically understanding that, we're talking about workplace health and safety. Essentially, how can we look after this army of workers more efficiently? If we mistreat our workers in any scenario, we're going to have a lot of issues. So health is about giving them good living conditions. Safety is about protecting them from toxins or poor soil management decisions. And one of those poor soil management decisions is working your soil too often, because every time you work your soil, you oxidize some of the organic matter. You also chop up the beneficial fungi that are in there. They don't like to be sliced and diced on a regular basis. So no-till farming, absolute transformation of soils. There's no debates about it because you had less disturbance of that soil. So if you can possibly farm or garden with minimum disturbance, that's always going to be better from a biological perspective. So what sort of things can you feed them? Well, if you're looking at the bacteria component, which is huge, it's massive, it could be tons per hectare of total microbe, 2.5 tons, for example, as a good soil of just bacteria in the top 6 inches. They like simple things, simple carbohydrates, simple sugars. You can feed them sugar, you can feed them molasses. There's also a natural acid called fulvic acid, which is considered to be the most powerful bacterial stimulant. But they're tiny. There's 500,000, is how small they are, on a pinhead, but they fix nitrogen, they deliver minerals, they support plant immunity, they produce biochemicals that stimulate our immune elicitors and protect disease in multiple ways. So we touched upon fulvic acid, much more than just a foliar. It promotes root growth, it dissolves minerals. It actually allows in low sunlight conditions for photosynthesis to continue. And there's been 6 papers published on that. No one understands how the hell it's working, but in low, particularly in Europe, where you've just had days and days with no sun and everything grinds to a halt because sunlight's part of photosynthesis, photosynthesis continues in the absence of, so they call it the second sun, which is almost a miraculous thing, but it's what happens. Detoxifies pollutants. I've just bought a huge apple farm, 6 million apples it produces, converting it to completely chemical free in a single season, which everyone says you can't do, but I'm going to prove, hopefully. I mean, there's hailstorms and there's late frosts, which we had, and a dozen other things, and the TAB gambling thing that well, actually makes TAB gambling look like child's play when you're farming on a larger scale. But one of the things I did, 42 years of chemicals, we went from really high doses of fulvic twice, and we measured before and after, and we removed the chemicals. We cleaned up that soil in a really short time. Soils are tremendously forgiving if you know the strategies. So you detoxify the pollutants, and of course fulvic acid does all these other things I've just mentioned, increasing moisture retention, magnifying nutrient uptake, stimulating bacteria, and so forth. So together there are these things called humates that are probably the most powerful tools in regenerative agriculture, farming, or whatever, or gardening for that matter. So humates together are called humic acid and fulvic acid. Now, they're what you're making when you make a good compost, so they're not some weird human-created acid. You're making humic and fulvic. The better the compost, the higher the levels of humic and fulvic acid are found in that compost, but they can also be extracted from ancient organic matters in the forms of certain types of brown coal. And so you get this concentrated material. Humic acid, fulvic acid feeds bacteria. It's wonderful, and it can do a whole range of other things, but humic acid is unique in its capacity to stimulate fungi, and every soil we look at when we do soil life counts has to have more fungi. So it could be argued to be the most important single thing to sort of almost to save the day, basically, because understanding that fungi, particularly mycorrhizal fungi, we now know that one species that's 90% lacking in our soils is responsible for 30% of all the humus on the planet, because it triggers the whole humus building apparatus of the soil with an exudate it produces called glomalin that puts the soil into hyperdrive and it starts building humus. So hugely important organism, and as are many other beneficial fungi in the soil who create this stable humus that lasts for 35 years minimum, which means it's out of the atmosphere for that time. That's carbon sequestration, and humic acid is the most powerful stimulant of fungi. So you can get it as a soluble granule. You can mix it up at 1 to 10, make your own humic acid. So really inexpensive, 30 cents a litre, I think it works out at, and we pour that through again at all 3 of my farms, and the results are tremendous. So just looking at the benefits just briefly, it increases nutrient uptake. There are 9 published papers, increases it by about 30 to 35% more available. Stimulates the 4 hormones that drive plant growth and plant resilience. Cytokines, gibberellins, auxins, betaines. It's actually an auxin-style hormone, so its major impact is to have that bigger leaf and bigger roots. It locks up enzymes that, see, pathogens produce enzymes that shut down a plant's immune system, so then they can march in and have their way with that plant. And what humates do, humic and fulvic both do it, they lock up those enzymes, so it makes it much harder for pathogens to facilitate their attack. Humic acid holds 7 times its own weight of moisture, so you can imagine that's going to be a benefit in dry conditions. The other essential, so we talked about humic and fulvic as essentials in regenerative farming or gardening for that matter. the other essential is kelp. And of course, you're surrounded by that, I guess, on the island. But why would we use kelp on the soil? Well, for a start off, it's got the full spectrum of minerals from the ocean, which is all 74 minerals, in arguably the perfect balance, because that's what seawater is considered to be, the perfect balance of all 74 minerals. A study in longevity research recently showed that a swim in the ocean on a daily basis, even 5 times a week, is linked to 12 to 15 times increase in longevity. You're surrounded by ocean, get out there and have your swim on a daily basis is the argument here for your own health perspective. So what else does kelp do? Well, it contains very high levels of a long-chain sugar called mannitol, which is a very powerful chelating agent. So anything you add to kelp, like zinc, you create a zinc mannate. A calcium mannate, which means it's much better absorbed. So, but the big thing, and of course, there's also the highest level of any plant in vitamins. We now know that vitamins stimulate plant immunity. Well, 4 of the key vitamins, the B vitamins, vitamin C, vitamin E, are really, really important for plant immunity. And it's the highest known source. And you might be thinking, should I be eating some kelp? Yes, you probably should, because it's also the highest source of iodine. And iodine in plants, we're now finding, has natural fungicidal qualities, but it's massive for your health, because your thyroid gland is the most important single mineral. And when we test people in my courses, we do hair tests, most people are iodine deficient to some degree. So kelp's a wonderful component, or should be a wonderful component. Of course, we see there's minimum thyroid issues in Japan because they eat much more kelp than what we do. But the big story about kelp in agriculture is that all plants require 4 hormones for everything they do: cytokinins, gibberellins, auxins, and betaines, from germination right through to post-harvest, and how long they last on the shelf, which is called delayed senescence, is driven by 3 of those hormones. And kelp is the highest known source of those 4 hormones, 40 times higher than the next closest plant. Every plant requires those hormones. They're made from minerals. We mined a lot of the minerals out of the soil. Most plants cannot achieve their genetic potential because of a lack of those 4 key hormones. And we bring in those hormones from the ocean, the gift from the ocean I call kelp, to address that scenario. One other story that we'll talk about before we complete is the story that naked soil is never good. Basically, soil doesn't like exposure. That's why nature fills the void. If we're learning, the definition of the word science in Webster's dictionary is adherence to natural laws and principles. It's all there, the perfect blueprint. We were supposed to learn from it. And instead we said, we could do better than that. No, we can't. We never will. And the sooner we learn and recognize that, the longer we're going to be here. So we look at nature and nature never leaves soil bare. It pops up something, even if it's a weed, because that's a living protective cloak over the precious topsoil to shelter, insulate, to sustain. Plants feed beneficial soil life. Remember, they pump a third of their 30% of their glucose they give away. Some of that glucose becomes humus, and some of it becomes a food and energy source for that army of organisms. There's also a constant dynamic flow of communication between plants and plants, which we've only recently understood, between plants and microbes, and between all forms of soil life. So it's a whole dynamic system that's absolutely fascinating, even to the point in forests that we've now discovered that there's a thing called the mycorrhizal network, through which water and nutrients and messaging saying, well, there's a disease coming, you better prepare your biochemicals to protect against that disease, happens via this mycorrhizal network. This is relatively new findings. And they've even found that the seed from a tree in a forest will float to wherever and land. And then it's down the bottom of trying to photosynthesize with no sunlight the most. So it struggles. And so the mother plant only looking after her children almost, pumps some glucose through the mycorrhizal network and looks after only its seeds. So it's weird, but it's what happens. So it's fascinating, really, in that context. So cover cropping is part of that understanding that naked soil is never good. And cover cropping offers so many benefits. So again, we look at what's the central, we're learning from nature. That's the definition of science. What's the central driving principle of nature? It's called biodiversity. The more the merrier is how nature works. And so we got it completely wrong to go into a monocrop model. It's the opposite of what nature wants. And so how we can counter that we've bought into, orchards of one crop or growing one vegetable crop or whatever, is that we bring in some cover cropping to bring in that biodiversity of different species. And it's called, multiple species or cocktail cover cropping. It helps manage weeds, because basically you filled that slot that a weed might have popped up in by having a cover crop, under your other crop or wherever. It feeds soil life, because the thing to understand is that while plants pump their glucose, it's not just glucose. They lace that glucose with substances that stimulate organisms that are going to deliver what they particularly need. If you're a banana plant, you love manganese. So you lace your glucose with substances that stimulate manganese-reducing organisms that make manganese available, because that's what you want. So every plant feeds a different group of organisms, and the more plants you've got, the more diversity of organisms you've got, which gives you more resilience, more protective, greater yield, and more fun when you're farming. So, of course, there's also the building of humus, the prevention. Like, it should be illegal to leave bare soil. When we're losing soil at 3 to 5 tonnes per acre, 7 to 12 tonnes per hectare, and the scientists have now told us we've got 60 years, there's nothing. There is nothing on the planet more important than topsoil. It's what feeds us. 10 billion people, 10 years, with another third of what's left gone, we're struggling. There's nothing more important than a soil health restoration at governmental level in every country in the world. And I meet with ministers across the world and try and drive that point home. So you've lost the glue when you lose the humus. When we have dust storms cover South Australia to Cairns, which we had one year a few years back, basically billions of tonnes of topsoil, that's a loss of the glue, the humus that holds those soils together. When our rivers run brown, as they always do, following a rainstorm event, that's a loss of the glue. That's the humus that we need to address. So the other story with cover cropping, particularly because some flowering plants, in fact most plants flower, but marigolds, for example, reduce biochemicals that reduce root disease, brassicas particularly to prevent nematodes, but trap crops for beneficials, particularly bees, but the whole story of insects and their importance. Recent German, it was really, the guy I heard talking about the initial release of these findings, he burst into tears as he described these findings. 27 years of study, not on farms in Germany, but in parks and wildlife reserves and wherever. But what they monitored was a 75% decline in flying insects in that 27-year period. Understand that the entire global food chain is insect dependent. It's actually hugely beyond. And one of the things is compare your windscreen. Now, I could have driven to my farm up at Stanthorpe 4 hours from where I am on the Sunshine Coast and would have had to change regularly. I wipe the windscreen regularly. I can drive up, there's a couple of splats now, and that's part of the success of neonicotinoid insecticides. They've been super effective. They've created colony collapse disorder where you can't even grow bees as a business anymore because 49% of the hives were lost last year. We need to step up and ban those neonicotinoids and understand what they're doing. So mulching, just a final couple of things in terms of protecting that soil, protects moisture, protects soil from extremes, stimulates soil life as they feed from that mulch, and of course, lucerne hay, the most beneficial of all mulches. And just touching upon the cover crop story, just some really fascinating science. Brazilian agronomist Ademir Caligari, Dr. Ademir Caligari, discovered that if you can put 5 families of plants, and this is something you can think about on the island because it is such a response, and I'm doing it on my farms all the time, but you put 5 families in a blend, and the 5 families are cereals, grasses, brassicas, legumes, and chenopods, or chenopods, the Americans call it. I'm not sure the correct pronunciation, but those 5, and chenopods are a small little group of plants, only everything from the beet family, beet family, amaranth, spinach, and quinoa. That's it. It's just a small little group. So usually you might have a bit of silver beet. It's only 1% that you have in your blend, so it's not a huge expense. It's only 1% of the total blend, but if it's not there, the magical thing I'm about to describe doesn't happen. So USDA scientists went out to check what was happening when pet farmers were reporting this tremendous change in soil structure with a single cover crop when they used the cocktail cover crop concept of 5 families. And what they discovered, only when you've got the 4 of them doesn't do it, the plant roots begin messaging each other in the presence of those 5 families, and the roots start pouring out substances called phenolic compounds. Now, that's what we drink green tea for, because they're wonderful antioxidants that stimulate every one of our 10 trillion cells. Well, it turns out that they do the same thing, those compounds, to soil life. And soil life effectively goes into hyperdrive and gives you this massive change in soil structure and breathing capacity of that soil in a single season. So wonderful thing to look for. Hopefully there's someone on the island that can put together a blend like that, or you can do it yourself or source it from New Zealand or Australia or whatever, to get one of those, even in a home garden, but certainly in a commercial system. I grew a ginger crop, a paddock that never had anything. Penetrometer went down maybe 8 inches, bang, there was a hard pan. It had cattle on it for years, so it had been compacted. a single cocktail cover crop, 20 in total. So it's not just 5 plants, but as many as possible of each of those 5 families. And so it was a 20 species blend that I had to go to 3 different shops to get the seeds. But the transformation, you could push the penetrometer with a simple push to the end of the hilt of that penetrometer in one 4-month cycle, 4.5-month cycle. And I don't know of anything else that can make that much change in that short a time. So that concludes a bit of a whirlwind. They often describe my talks as drinking from a fire hose. So I hope you're still surviving, but I'm quite happy to take some questions.
That was awesome, Graeme. I've got a list of big notes, long list of notes here. I know what I'm going to do this weekend. So that was fantastic, mate. Thank you. We'll go to some questions then. Anyone got any specific questions? A bunch of, I know 1 or 2 of the farmers on the island are here with us.
Good.
Here's your chance to ask Graeme some questions for yourself. You can type them in or you can unmute and ask yourself directly.
So I see there's one there from Rebecca that's come up. Shall I just...
yeah, you go ahead, bro. Yeah.
So basically, is wormweed a good foliar spray? Yeah, it is. I mean, it's actually quite... basically, it's if you're going to put it on the leaf, you put it with something. So you know, it's going to be great from the point of view of bringing all these beneficials to control potentially disease on the leaf. But there's a second thing. You never put out a microbial, whether it's a compost tea or wormweed, by itself, because you've wasted an opportunity. So plants take up nutrients via their stomates, that little pore I mentioned. And that stomate can open up to 7 times, like a little mouth, its normal size. And when we say, oh, what stimulates stomatal opening? Well, potassium. If you're down on potassium, the stomate doesn't open, so you're not going to get a good response with foliars and so forth. Number 2 is birdsong. How wonderful is this interrelated nutrient thing? They discovered that the frequency of early morning birdsong opens the plant stomach so it can drink some dew, bit of dust on the dew, there's some minerals, it has a drink and a feed first thing in the morning, stimulated by birdsong. But the third thing is the introduction of something like wormweed, where we're talking about 5 billion organisms per teaspoon in that material, all of whom are taking in oxygen and breathing out CO2. And that's what the stomate's there for, is to take up. And when there's a sudden influx of CO2, which is what happens when you foliar spray wormweed, the plant opens its stomates to its little mouth to full size to get there. I'm having some of that, and grabs that CO2. So you put something with it to get better uptake. So if you need some calcium, or you need some fish fertilizer with all the trace minerals, whatever, you put it with the wormweed, you put the microbes behind the minerals. Same story in your health. If you're taking zinc, if you're a man and you should be taking zinc last thing before bed for your prostate health, prostate cancer is now the largest killer of men on the planet, and almost all of us are zinc deficient. It's the biggest, most important mineral for protection of that particular gland. You're going to take it with a probiotic. You're going to put them, and it's shown it increases uptake by about 40%, 42% to be exact. So you're going to take a probiotic with your zinc supplement at night, simple enough. Well, you're doing the same thing. You basically, it's like a probiotic. You're putting the microbes behind the minerals when you foliar fertilize. Okay, long answer to that question.
That's amazing. I've got a question, Graeme. If I want to plant out a section of paddock that's currently under grass, and I wanted to go to a no-till system, I get that digging the soil up is not the ideal thing all the time. So. Yes. Do I need to dig it up first, or what's the process to get to turn paddock or grass into garden, if you like?
It depends on what's colonising that grass as it stands. Yeah, you're going to have to initially you're going to do one cultivation. But if you've got something super invasive like cooch or kikuyu, like Norfolk is all the kikuyu, it's pretty hard to sort of every little tiny piece of root regrows and so forth, and there are huge question marks around glyphosate. I mean, there is no doubts at all that glyphosate won't be here in 5 years. I mean, there's just the lawsuits that Bayer are now facing is, $1 billion each for the last 2 lawsuits that went through. And there's I was talking to the head of Bayer in Australia, and there are 15,500 lawsuits waiting. So do that times $1 billion, and you realise it's not going to be here in a relatively near future. But there's for something that will kill systemically once, and then the trick with glyphosate is you put some fulvic acid and you acidify the mix right down to 2.9, where you can use much less, as little as half as the amount, by using citric acid, dropping the pH of glyphosate to 2.9, and then you put fulvic acid to speed its breakdown. That's one way to at least make it more sustainable. You just do that once. If you're organic, you can't, but just with kikuyu, it's just such an issue that you kill it off, and then you're right, you can manage it. and then you're not going to use that again. But alternatively, in your situation, what's the major grass there?
Look, I don't know the species, but it's not that kikuyu running type matted. It's not.
Okay.
So I don't know what it is, but it's.
Yeah, so that's usually you'll usually, like even on my farm, we just did a whole area in cover crop, and we just need some rain now for it because it's not irrigated. But basically we had cooch, and so we actually cultivated more than I'd like to have, but we had to get rid of that cooch. And so you bring it up and it dries, and you bring it up a second time and it dries. You turn it over a second time. We just use a little rolling cultivator, but we got rid of it, and now we can put the cover crop in and it goes fine. So just that initial disturbance is necessary to get started. Okay. So you haven't got the competition from the grasses.
Cool. All right. Cool. Other questions?
I've got it. It's Karen here. I've got a question. Two questions, if that's all right.
Go ahead.
And this is basically home gardening questions. So here on Norfolk, we've put in some raised garden beds and netted them to try and stop the birds from getting at our plants.
Okay. And
we've got lots and lots of worms in there. We have a small worm farm. We've been able to get lots of worms. Can you actually get too many worms in a garden bed?
No, you can't. It's interesting. Even if you've got a worm bed, or you say one of those 1,000-litre containers that we use with the worms, it's a really good idea to either pull out a kilo from time to time and start a new bed, or sell them, which is $100 a kilo to sell them over here, and they're in quite strong demand because worms basically, when they get, unlike humans, when they say, okay, enough's enough, we've got this area and we've got this food, they stop reproducing. Normally they double up every 6 weeks, but once they get to maximum numbers, they just stop. Unless you're feeding them heaps of stuff, then they'll keep going because it's based on their food source. But they just naturally self-modulate, sort of thing, which humans don't do, obviously. So that's quite cool. So you can't overdo it. They look after themselves. They'll basically define their own numbers based upon the food source available. Now, I was in Canada, and the most productive soil I've ever seen. He's done my course 4 times, and they've got an organic farm, but they've got a 1 acre vineyard, 1 acre greenhouse where he does everything. He's got cover crops under his tomatoes and capsicums and so forth, and little insect attractors for beneficial predatory insects and all sorts of things. And he uses actually huge amounts of liquid fish that worms love. That soil had about 75 earthworms per shovelful is what we counted, and it was a small shovel. And massive amounts of earthworm castings, but his yield, a little 1 acre greenhouse, 1.27 million Canadian dollars a year from 1 acre. That's the potential of nutrition farming at its maximum of understanding that system. So yeah, you haven't got a problem from that perspective. They'll take care. They'll modulate according to what you're giving them, basically. But they love liquid fish. Remember that. If you're feeding them, they'll just keep breeding. Okay,
thank you. Yeah, every handful that I ever pick out of these garden beds is full of worms. So there are just so many of them.
Well done. You've done a great job.
Thank you. And the other question that links to this a bit is I have a horse, so we compost. I pick up the horse poo every day and we compost it, and then use that to replenish the garden beds and the garden. And because of the kikuyu grass over here, I supplement my horse with a calcium, plus it's got magnesium and a couple other things, but mainly to make sure she gets enough calcium. Yeah. Would the calcium, do you think that's coming out in her manure, be useful going back into the garden beds? Because it seems to make such a difference.
Absolutely, definitely. There's no doubt about that. It's a great way to put things, to do it that way and put it through the animals. The only thing to be careful of, and I guess you are doing it right or you wouldn't have the earthworms there, but like we tried, for example, in demonstrating that how you make a trichoderma compost, as I mentioned, that simple idea of half straw, half cow manure, and nothing happened. We had and so we were using conventional cow manure from a dairy farmer down the road, and because of all of basically the wormicides that he's putting down the throat of the animals were actually killing the organisms. So just to be careful that you're not putting too many wormicides down the horse's mouth, and maybe you're not if you've got those earthworms, or maybe you're getting away with it, but that's just one issue. We had to source organic cow manure in the end to successfully to brew up the trichoderma because they didn't like the wormicides.
Okay, yep. Yeah. Thank you.
Okay.
Another one there in the chat, Graeme.
Hi, Mitchell. I see. Good to see you here, mate. So I'm just looking at your question here. I've not started a worm farm. Can I temporarily use copious amounts of potash to introduce calcium carbonate into the compost? I see Mitchell sent us regards, so it's from Martin. Okay, hi Martin. Can I temporarily use copious amount of potash to introduce calcium carbonate? I don't quite understand. Are you talking about when you're talking about potash? Potash is the word for potassium, or are you just talking about the ash from the fire? I'm just not quite understanding that question. Maybe that could be clarified. So the question is, I've not started a worm farm. Can I temporarily use copious amounts of potash to introduce calcium carbonate into the compost? Well, potash is either potassium, sulfate or whatever, or you might be talking about the ash from the fire. But no, not normally. The normal way to introduce, what you're introducing with ash from the fire is potassium, basically. That's why it's called potash. That's the principal mineral in wood ash. And it's a great thing to add into a compost. In fact, it's just a wonderful additive. Never throw out your wood ash. If you've got a compost, or give it to someone who's got a compost, because it stabilizes the potassium. It's also got all the other minerals concentrated in the ash. The minerals are in the ash. The minerals that grew that tree are in the ash. How you analyze with a leaf analysis is that you ash the plant and you analyze the minerals in the ash. So you don't throw out ash. It's a tremendous waste, and it's wonderful to complex it in the compost. The microbes then build it in and create it into humus where it'll be stable, and all the minerals will be stabilized and magnified and so forth. So that's the secret there.
Well, that's what I was referring to, Graeme. Ash from the combustion stove, as well as an incinerator, added to the compost.
Yeah, so the calcium levels. So the calcium levels, there's a little bit of calcium in there, but mainly it's potassium, which the island needs. The soils from the tests we did, there was quite a strong need for potassium. So it's a wonderful additive, but you'd probably be better off putting a little bit of limestone into the compost as well. I mean, all of the commercial composting strategies globally, and there are no exceptions, all of them, whether it's biodynamic composting or what's called controlled microbial composting, which is a huge thing that people do commercially, even anaerobic composting, all of them on each layer, whether it's the carbon layer or the green layer, the plant matter layer, they put a sprinkle of lime. So liming is just a part of composting strategy, and you're getting some calcium that's then complexed into the whole compost. You'll get a little bit out of that ash, but mainly it's potassium and other minerals and things, but potassium is dominated by, and there's something like 18% potassium in the ash from your stove, so wonderful thing to put it into your compost.
The other thing that goes in currently is crusher dust.
Yes.
Now, the crusher dust here, it hasn't been analysed to my knowledge, but on the Sunshine Coast, we used to get a crusher dust from Moy Pocket, which had an inordinate amount of lime in it. That was absolutely fantastic. You could virtually grow on that.
I do exactly the same way. Actually, I can't. It's funny you should say that, because I'm on the Sunshine Coast, and that's exactly where I get my crusher dust. And I've got a 7-ton tipper, and I take a load up to my Sandthorpe farms every time I go up there of that crusher dust from my pocket. Yeah, it's wonderful stuff. Sorry, what were you saying?
Yes. Obviously, adding that doesn't just provide this very high amount of lime, depending, of course, on the overall contents, but it also gives you a breakdown over years in several minerals, a pretty wide spectrum minerals.
Yes. Well, the other story, and it's a little bit of a long answer, but I'll try and do it briefly, that many people aren't aware about is relative to crusher dust, is that there's this thing called paramagnetism. So, there's a wonderful scientist called Professor Phil Callahan, who discovered that why volcanic soils are so much more productive than non-volcanic soils, and the most productive soils on the planet are the volcanic soils. And he discovered that they had this capacity called paramagnetism, where they could actually draw in, it's weird, it's an energy from the atmosphere. It's not some weird airy fairy thing. It's just extra long frequency radio waves, which are present just like all radio waves are in the atmosphere. They come from lightning originally, because lightning, 4,000 lightning bolts every minute somewhere on the planet, they convert to extra long energy, never disappears. It converts to another energy form. So it's extra long frequency, and basically volcanic soils can pull that in, convert it to tiny light particles called biophotons, which are now measurable, and that gives light to the roots and the organisms. So it turns out that there are certain materials, if you've got a non-volcanic soil, that you can add to your soil that are highly paramagnetic, and there's a meter that measures paramagnetism, and you can basically add that light factor in, which gives a tremendous fertilizing type response. And the Moy pocket is the highest paramagnetic, that's why I source it, on the coast here. And there are many good sources, and I'm not sure what's available on the island, but you're welcome to send over a sample. Just mail it over in 100 grams, and we've got the meter here, and we can tell you if it's any good or not from that perspective, from a paramagnetic perspective. You want to be above about 1500 CGS, it's called, on the meter, and Moy pocket's 3200, so it's wonderful. Yeah. So
several years ago, there was a product called Norfolk Island Gold. And I believe it's no longer available, so Mitchell tells me. Is there some sort of a recipe, for want of a better word, to put that together on the island?
Yeah, I could provide. Yeah, we based on the soil tests that the government at the time, very you know, it was a really interesting thing to see a government pay for a bunch of soil tests to see what the local soil producing food producing soils were doing and what they contained and what they needed. And on the strength of that, we thought, well, they were pretty much universally lacking about 5 or 6 minerals, including potassium, as I mentioned, but copper and boron were 2 of them. And interestingly, copper and boron, in terms of, you know, their impact on human health, really strongly linked to arthritis. And there does seem to be an inordinately high, in my opinion, just in the time I spent there is quite a lot of arthritis on the island. And, you know, you are pretty much what you eat on the island, because you know, previously you were importing so little food. So yeah, from that perspective, so I'm raving on here, so I'm going to shut up. Yeah, sorry. Did I answer the question? I'm just...
Yes, could that?
Oh yeah, so I could provide you with, but yeah, I could. I didn't know that we'd stop making Norfolk Gold. Maybe Mitchell just stopped import, because Mitchell was importing it. So we made up a compost.
Mitchell tells me that you can't get it anymore.
Yeah, so we used to have. Well, I'll check on that, but maybe maybe that's right. Maybe that's right. So if that's the case, I'll just provide you with the guidelines of what you need. And, you know, we had it in a compost base with all the minerals. It wasn't all the minerals required for everything, but specific to Norfolk in terms of those 5 minerals that were lacking in every soil that we tested. I think we tested 40 or 50 soils, and all of them had that same lack. So yes, certainly I can give you that. If you email me, it's just graeme@nutritech.com.au. But anyway, you can source that email address and email me, and I'll provide you what you need, and you could definitely do it yourself.
One controversial topic, Graeme, which might feel some people leave a bit of squeamish there, is blood and bone.
Yes.
Now, there's an old school of farmers who I've met on the Sunshine Coast and other places like Tasmania, who say it is okay to add the odd roadkill to your compost heap if you've got a big enough one, and you add some really valuable ingredients. Now, it doesn't suit everybody, but what's your thought on that?
It's tremendous. You know, there's an argument with composting that there are static piles and there are active piles that you turn, you know, and commercially you use a compost turner to turn them regularly, if it's particularly in the first 2 or 3 weeks. But I remember meeting with a guy who wrote a book called The Secret Life of Compost, and he was describing how active a static pile, which, you know, you set up, it takes twice as long, but you turn it only 2 or 3 times during the cycle, but they can be so active at the height of the sort of compost maturing process that he described, you know, one of his sites. He makes 250,000 tons, this bloke, Malcolm Webb, his name is, Malcolm Beck. He makes 250,000 tons across the country on various sites. And he's talking to a farmer across the fence when he's checking out one of his piles. And the farmer says, "Oh, I've lost, my old horse died. I'm going to have to get an excavator in to bury him. I haven't got one." And he said, "Well, have you got a tractor with a front bucket?" And the guy said, "Yeah." He said, well, you bring the horse over, we can lift him up, we can open up the size of this fully active compost heap, and we've just put the horse inside it. So this is a complete horse. It's not just a little bit of squashed kangaroo or whatever. So they put it in there, and 6 days later they come back and there is absolutely nothing except the horseshoe. So the bones even have broken down in that time. And of course, you know, you're talking about bones, and of course there's a massive source of calcium and phosphate and silica and so forth, and all the trace. I mean, it's a tremendous thing to add into your compost realistically if you can do it. There's no no arguments or debates. As long you can't do it to start off a compost. You can't take a whole bunch of your bush rats and put them into a compost from the start, because it'll be rotting and stinking. It's only when it's fully active, you open it up, put it in. It's got to be really hot when you put your hand in it, put it in there, and it'll break down so quickly if you've got a good compost pile. And then you've got all those nutrients through the compost. It's a great strategy.
Yes, yeah, that's good to hear. We've even at one stage added the stomach contents of home slaughtered cattle to the heap, and that in itself actually accelerated decomposition on the heap.
Yes, it's called paunch, and there are composters here, commercial composters, who that's their major ingredient, because you've got part of the rumen happening with all of that, all those organisms, including lactobacillus, that are so active that then go to work in the compost. So yeah, that's a great strategy.
I believe it's a resource we're wasting on the island here.
Yeah, just
anyway,
throwing
other people might have burning.
Throwing it over the cliff for those.
Other people might have burning questions, so I let you go. It's good to see you looking well and showing some white teeth. You must have developed the formula of continuous, how would you call it, rejuvenation.
I wish I could claim that. What actually happened just personally was I had root canals, which people have, I've had biological dentists say, you know, root canals are no good. You don't know that they've got this infection because you've got no nerve in them. And I had 5 of them, and they were actually rotting my system. And they told me that might even kill me, because it can give you a heart disease based on that infection in your root canals. And they said, by the time we pull them out, you know, you've had other gaps amongst your teeth and everything. You might as well have implants. So I got a quote, and for what's called 4-on-4, 4 posts into your top drawer and 4 on the bottom, and then they put this zirconium thing on top. That was 70,000. And then I looked it up, and it was a 50% over 5 years fail rate. We only got 4 posts holding them. So I said, if you would do it right, which is 10 posts on the top and bottom, what would that cost? It was 152,000. So I went to India and did it for 19,000. So that's where these white teeth came from.
Hey, we're going to have to wrap this up, guys, because we're actually over time. But is any final thoughts from Martin? Thanks for your comments, mate. That was really interesting. Rebecca and Ruby, anything final? Last questions? We might have to leave it. All right, we appear to be done. Graeme, that was my drinking from a fire hose is about right, but it was inspiring, mate. I thoroughly enjoyed that myself, and I've got a shopping list of things I need to go and pick up for my garden this afternoon to get into it. So I appreciate your insight and your passion and your immense knowledge around this. Thank you so much.
That's a pleasure.
Yeah.
Adam, is there one last question I can get in?
Yes, but I'll need a quick answer, Graeme.
Okay, I'll make it quick.
Okay, right. This is about the in vogue of juices and quick meals out of several veggies or groupings of fruit, etc. There's one aspect that we forget from a nutritional point of view. It might give you the right blend of nutritional ingredients. However, it shouldn't be forgotten that when people go overboard, there is a downside in terms of dental health. There's nothing like mastication when it comes to ingesting good food.
No, I agree completely. And of course, you know, we weren't designed to drink a 250 ml glass of orange juice that involved 8 oranges with none of the fiber. And that the other downside, I mean, juices are wonderful, much better than drinking Coke, you could argue, but 8 teaspoons of sugar in a 250 ml glass of orange juice, and there's no fiber to counter the impact of that sugar. So it basically speeds the production of insulin. Insulin speeds cell division and shortens your life. And that's the secret of longevity. When they did the study of centenarians, a huge global study, the only common denominator between literally thousands of centenarians across the globe in a 3-year study was low fasting blood insulin. And so, you know, basically anything that spikes. And so what stops things spiking your blood sugar is the fiber component. So you're supposed to eat the full orange, not just drink the juice, because you will spike blood sugar and shorten your life, essentially, is the bottom line.
Good tip. Yeah, it's really important, isn't it? When you think of it in context. Yeah. No, good point, Martin. Thank you. All right, Graeme. Thank you. Thank you, everyone who's been on the call. It's been really insightful, and we look forward to, I'm going to be on the island in a couple of weeks' time, and really looking forward to meeting the farmers and the and seeing this amazing Norfolk soil and tasting the produce. So,
I love it.
Yeah. Thank you all. Talk to you.
Yeah, thank you, everyone. It's my pleasure to chat to you. I hope I get over myself soon to catch up with everyone. Thanks.
Thanks, Graeme. Well done.
See ya.